So another example of ANOVA, a consumer agency randomly selected auto drivers who had similar driving records, cars, and insurance policies. The provided table gives the monthly insurance premiums in dollars by these drivers insured with one of the four insurance companies. So we have four different companies here. This is made up data, so don't actually think it's true. We're at a 0.05 significance level. We're testing the claim that the mean monthly insurance premiums are equal. Again, very common with ANOVA to be having that be the claim. So H0, H1. So in this case, I might write mu of State Farm equals mu of Geico equals mu of Farmers equals mu of AAA, maybe something like that. And that is our claim. So don't forget, that is the claim that they are equal. And then we can say at least one of the mean monthly payments is different. Okay, so we will be doing this on the calculator, just using the ANOVA, but I will mention really quick coming back here that if you do look at the mean of each of these, if you were to find that data just as from an interesting perspective, if you found the mean of each one, you'd get $85, $84, $76.75, and 77. So just by looking at them, I mean, the largest difference is $8. So you can see that all of them fit within that $8 span. There's only a range of $8 on the mean. So thinking about that, along with sample size and stuff, may make you think about, do you really think you have enough evidence to say that at least one of them is different? So our test statistic, I really am just going to take this right from the calculator this time. It's way too much work to do the test statistic by hand. So if you want, you can pause, put all the values into list 1, 2, 3, and 4, or any 4 lists that you want. So you can pause and do that. Once you've done that, you're going to go to tests, over to stat, over to tests, and then the bottom one is ANOVA. There's 4 lists, so you're going to need to put in list 1, comma, list 2, comma, list 3, comma, list 4, and then close it up, press enter, and that's going to give you everything you need. So the first thing you see is the test statistic. It is F star 2.16712. I'm just putting some decimal places on there. But I want you to see that the 2 numbers that is used for that is MS. So in your calculator, it's MS factor, so I'll put MSF. MS factor, that's 156.458. And then dividing that by, if you scroll down in your ANOVA, you should see MS error, and what that is 72.196 to 3 decimal places. And that ratio is what gives you the 2.1672. So if you remember from the other problem, that's looking at the variance between samples and dividing it by the variance within the samples. So how much the samples vary from one to the other in the 4 groups, and then below is how much they vary within themselves. So that's what those numbers are. That's what they're measuring. But all we're going to do now is take, and I've lost it, so let me get it back here. We're just going to take the p-value to get our, I'm going to put it up over on the side here just due to spacing. So the p-value you'll see from the calculator is 0.1142. Not a small p-value, not a particularly small p-value. Our alpha here is 0.05, so we can see that our p is high. So the idea here is that your the value that we get, this test statistic sits like 2.16712. And because of that, there's a lot of area on the right, meaning there's a high probability that you could get that kind of data that we got, sample data, or data more extreme by chance, even if the null hypothesis is true. So we end up with this. And like I said, you could use tables for this, but the tables are, you can actually Google it, the F distribution. I mean, it's tables upon tables upon tables because there's multiple things that have to go into finding the critical value you'd want. But you could find a critical value, and that critical value, if you did find it, just to help you to understand that you could do this in two different ways. If you did use the tables and find a critical value, it would be out here. And what you'd be finding is that that 2.1672 sits to the left of it. So similar to the chi-squared, you could do this using critical value. It's just the table is so complicated that we don't use it. We just focus on p-value in this case. But it's kind of an interesting thought. So now there's our test statistic. We can see our p-value. Our p is high, so the null will fly. So we're going to fail to reject H not. And then our conclusion, we have there is not sufficient sample evidence to warrant rejection of the claim that the mean monthly insurance premiums are equal. So if you truly understand what hypothesis testing is about, you could answer this question. Does what we just found mean that it doesn't really matter which company you choose to get your insurance from, because they're all about the same? Or did what we find tell us that in reality, it really matters which company you choose, because it's a big difference in how much you're going to pay? And if you can answer that question correctly, you have completed statistics well.